Good evening, especially to my professor, Mary Deliwanag. I'm Maria Carlo Mendogan, taking a PhD, a Bachelor of Science in Business Administration, major in Management Information System. And now, on this activity, I will present and demonstrate the knowledge I attained throughout the course by demonstrating the theories, configurations of different networking devices and application of the topics. So let's start. So the topic I choose is the Group 1, Introduction to Scaling Networks, LAN Redundancy, and Link Aggregation. A scaling networks introduction. As the moment business grows, so do its networking requirements. Businesses depend on the network infrastructure to provide mission-critical services. Network outages can result in lost revenue and lost customers. Network designers must design and build an enterprise network that is scalable and highly available. Network redundancy is a key to maintaining network reliability. Multiple physical links between devices provide redundant paths. The network can then continue to operate when a single link or port has failed. Redundant links can also share the traffic load and increase capacity. Link aggregation is the capability to produce one logical link using several and physical between two devices. Network devices and management functions care for the aggregation group of multiple Ethernet connections as a single link. Scaling networks. Effective network design implementation requires a solid understanding of the current state of recommended network models and their ability to scale as the network grows. A computer network designed to cater and is capable to support the needs for growth is called scalable. A well-designed network controls traffic and limits the size of failure domains. Computer network architecture defines the design of these physical and logical components. It provides the specifications for the network's physical components, functional organization, protocols, and procedures. Computer networking refers to interconnected computing devices that can exchange data and share resources with each other. Network design involves evaluating, understanding, and scoping the networks that we implemented. This is the hierarchical network model, the access distribution, and the core. To meet these fundamental design objectives, the network must be built on the basis of a hierarchical network architecture that allows flexibility and growth. Cisco hierarchical model. A network technology hierarchical design involves dividing the network into independent layers. Each layer or level in the hierarchy provides specific functions that define its function within the general network. This helps the network designer and architect to optimize and select appropriate network features, hardware and software to perform the specific functions of that network layer. Hierarchical models applied to LAN and WAN design. A typical design of a corporate campus hierarchical LAN network includes the following three layers. Access layer provides network access for workgroup and users. A distribution layer provides policy-based connectivity and controls the boundary between the access and core layers. Core layer provides fast transport between distribution switches within the business campus. The benefit of dividing a flat network into smaller and easier to manage blocks is that local traffic remains. Only traffic destined for other networks is moved to a higher layer. Layer 2 devices in a flat network provide few opportunities to control, broadcast, or filter unwanted traffic. As more devices and applications are added to a flat network, response times degrade until the network becomes unusable. This is the network topology diagram. Actually, this is the result of our previous activity for this topic. So these are the devices needed: the router and the switches, the PC or laptop, then the printer, the interfaces, and the subnet mask. This is the video clips in configuration of networking configuration. This is to show you that I'm the one making this activity. I'm only attaching the previous activity I made because we are in hurry because my term will end tomorrow, March 12. This is only the proof that I'm the one making my activity, and I learned a lot for this course. So we are configuring the routers for the networking. This is the result of the networking configuration. Let's proceed to the next topic. The LAN redundancy. Network redundancy is a key of maintaining network reliability. Multiple physical links between devices provide redundant paths. The network can then continue to operate when a single link or port has failed. Redundant links can also share the traffic load and increase capacity. Multiple paths need to be managed so that the layer 2 loops are not created. The best paths are chosen and an alternative path is immediately available should a primary path fail. The spanning tree protocols are used to manage layer 2 redundancy. Redundant devices such as multi-layer switches or routers provide the capability for a client to use an alternate default gateway. Should the primary default gateway fail, a client can now have multiple paths to more than one possible default gateway. First hop redundancy protocols are used to manage how a client is assigned a default gateway to be able to use an alternate gateway should the primary default gateway fail. This chapter focuses on the protocols used to manage these forms of redundancy. It also covers some of the potential redundancy problems under CentOS. Redundancy at OSI layers. The three-tier hierarchical network design that uses core distribution and access layers with redundancy attempts to eliminate a single point of failure on the network. Multiple cable paths between switches provide physical redundancy in switches network. This improves the reliability and availability of the network. Having alternative physical paths for data to traverse the network makes it possible for users to access network resources despite path disruption. The following steps explain how redundancy works in the topology shown in Figure 1.1. The PC1 is communicating with PC over redundant network topology. When the network links between switch 1 and switch 2 is disrupted, the path between PC1 and PC4 is automatically adjusted to compensate for the disruption shown in Figure 1.1. When the network connection between switch 1 and switch 2 is restored, the path is then readjusted to route traffic directly from switch 2 to get to PC4. And this is the Figure 1.1, the financial algorithm introduction. The redundancy is in a hierarchical network for many organizations. The ability of the network is essential to supporting business needs. Therefore, the network infrastructure design is critical business element. Path redundancy is a solution for providing the necessary availability of multiple network services by eliminating the possibility of a single point of failure. Note the OSI layer 1 redundancy is illustrated using multiple links and devices, but more than just physical planning is required to complete the network setup. For the redundancy to work in a systematic way, the use of OSI layer 2 protocols such as SDP is also required. Redundancy is an important part of hierarchical design for preventing disruption of network services to users. Redundant networks require adding physical paths, but logical redundancy must also be part of the design. This is Also the result of the activity I made, the previous activity I made. So I will show you the clips that I'm the one doing my activity. So hopefully our instructor will uh, give the chance because I'm catching my term that will end on Saturday. So this is the addressing table, the device interfaces, the IP addresses, and the subnet mask. And the objective of this activity is to build a network and configure basic device settings and determine the routes bridge and observe STP port selection based on forecast. Redundancy increases the ability of devices in the network topology by protecting the network from the single point of failure. Redundancy in a switch network is accomplished through the use of multiple switches or multiple links between switches. When physical redundancy is introduced into a network design, loops and duplicate frames can occur. The spanning tree protocol (STP) was developed as a layer 2 avoidance mechanism for redundant links in switches network. STP ensures that there is only one logical path between all destinations on the network by intentionally blocking redundant paths that could cause a loop. I will use the show spanning tree command to observe the STP selection process of the root bridge. I will also observe the port selection process based on cost and priority. So this is the video clip. For the previous activity I made. So this is the building a switch network with redundant links. We are configuring the switches now. To make it short, So next we are in the link aggregation. The introduction. Link aggregation is the capability to produce one logical link using several physical links between two devices. Network devices and management functions are care for the link aggregation group of multiple Ethernet connections as a single link. Link aggregation allows load sharing among multiple physical links rather than having STP block one or more of the links. Ether channel is a type of link aggregation used to switch networks. Now you can configure Ether channel either manually or dynamically. The dynamic method of Ether channel configuration is Cisco proprietary port aggregation protocol and the I223 the defined protocol configuration control protocol LECP. Usually the link speed between switches may be 10 Mbps, 100 Mbps, 1000 Mbps, and 10,000 Mbps. Normally, if the redundant physical links are established between the two switches, the spanning tree protocol blocks all redundant paths of the same switches except one. It may be possible to use faster links such as 10,000 Mbps. Adding faster links between access distribution links are very expensive as the speed on the links access links increases. The fastest possible port in the aggregated link is not enough to aggregate the traffic coming from all access links. The figure 1 illustrates the axis and according with the STP, we know that if STP is enabled by default in switch devices, STP will block redundant links to prevent routing loops. Traffic coming from several links, usually 10,000, 10, 100, and 1000 Mbps aggregates on the access switch and must be sent to distribution switches. So a link with a higher bandwidth must be available between the access and distribution switches, and the STP will be higher link is not enough for the incoming traffic. This is the figure 1, and so how we can increase the speed between the core and the access layer or any other switches. We can multiply the number of physical links between the switches and increase the overall speed switches to switch communication. The method used to multiply the speed of several numbers of links together is called Ether channel. So this is the figure 2 illustrating the Ether channel. So this is the figure 2 Ether channel. As the Ether channel technology advances, some are here to stay. In Ether channel, there are two basic types of dynamic and channel group protocols. Port aggregation protocol PAGP, which is the Cisco proprietary protocol, and link aggregation control protocol LECP, which is IEEE standard. In this exercise, we will use LECP, which is more interesting because it is multi-vendor application Ethernet channeling. LECP uses two types of port modes, active and passive LECP active mode, and conditionally forms of LECP dynamic Ether channel, whereas passive will only accept LECP negotiation attempts from device set to active. LECP is commonly used for server in IAC teaming with Broadcom or Antornix that support 802.3 LECP. This ensures that the server has two connections to each switch, rather it is stuck with switch for redundancy or a blade chassis, whereas the links are on different blades with one NIC goes down, connectivity to the server is not lost. So this is the result of the activity ID plus previous topics. So let's see there. So this is the established consultation with the router and the switches. This is the configuration and the interfaces we used. So let's watch the video clips. Excuse me. Sorry, I'm just wishing my instructor well consider my video clips because my term will end tomorrow. Then it will, and after this video, I will upload this in YT for she can check. And then I will share the link and I will submit the link to her. I don't have time. I don't have enough time to make another new configuration for every topic because we are employed. So I have work, so I have to make a new configuration. So I used my previous activity to show that I am the one who make my To make it fast, so I will fast forward. So ito na po yung resulta ng mga configuration natin. So they are communicating each other from router 1 to router 2 and the switches. They're communicating each other. So it's the end of my presentation for this activity, and I hope my Professor Meridel Aliwanag will give consideration for my situation as I am working while I am studying. So hopefully she will consider these video clips that I did not make new configuration because of my work conflict. I didn't have time. I have only a short time with me, and our electricity is not yet stable. So on and off yung electricity namin at saka yung internet ay hindi pa stable dahil po sa bagyong ulit. So, hopefully sure consider na this activity. Thank you for watching. Bye.